Okay. Our next chapter is trigonometry, which deals with triangles, sharp-pointed triangles. You have learned about triangles in the past. Do you remember which side is the hypotenuse in a right-angle triangle? Across from the 90 or the longest side, right? You say like this, but I could turn the triangle any way. So I don't know if this one necessarily is, yeah. Now, we are going to this year talk about adjacent sides and opposite sides as well. And that's going to depend on which angle we're talking about. So, how do we label triangles? Generally, we use capital letters for the points. So I can go A, B, and C. And then what is opposite the letter? So this side would be little a, this side would be little b, and this side would be little c. And I chose A, B, and C so that in this case you could see a squared plus b squared equals c squared. But the a squared plus b squared equals c squared only works when c is the hypotenuse. So in that formula, a squared plus b squared equals c squared, the hypotenuse is always the number by itself. Does anybody know what this Greek letter is called? When you see this, if this was English class and I said it's your turn to read the notes, the Greek letter, what would you say? No. 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 I'll give you a hint. It starts with a T. All right. Wait. Oh. Yeah, this is like the worst Wordle ever. They give you the first four letters, and you still don't get it. There it is. Theta. You said that 30 times, along with about a billion things that were wrong. This is the Greek letter theta, and we use it a lot in trigonometry. So when we're talking about an angle, so I draw some triangle, right angle triangle, and I label the angle theta. If the angle theta is here, we would call this side the opposite side. This side is still the hypotenuse. And this side is the adjacent side. Have you ever used the word adjacent in the English language for anything? No? Okay. If you, right now I am standing adjacent to Truson, which means I'm right beside him. Okay? Something that is right beside. So this angle is right beside this side, so we call it the adjacent side. If I drew a right angle triangle, the exact same one, but I labeled this side or that angle as theta, now this is still my hypotenuse, but now this is the opposite side, and this is the adjacent side. So we use opposite and adjacent in reference to an angle, and it depends which angle we're talking about. So does it make sense that the opposite and adjacent could change depending on what you're talking about? But the hypotenuse will always stay in the same place. So if I was talking about this angle, then this is my opposite side because it's right across, opposite of that angle. If I'm talking about this angle, then my opposite side is at the bottom because it's right across from it. In a triangle, we call the ratio of the opposite side over the adjacent side the tangent ratio. And this button is on your scientific calculator. Ooh. Let's see. And I learned something about the scientific calculators that I think will help a lot of people. Okay, so I'm going to see if I can. How many people bought a Casio calculator from the school? Either first edition or second edition. Okay, I want to show you a couple of things that can be really handy. I know you've got one. So first of all, I want you to go Shift and Setup, and I actually want you in the math one, number 1. Most of you, I might have even changed it to the line 1. I want you to change it to the math one, number 1. Because if you change it to the math one, number 1, then you can use the fraction button, which is really nice. That fraction button is going to be helpful. So you can do stuff like 2, oops, here we go. All right. Fraction button. 2 divided by, put the 3 in there, 2/3 plus 1. You can do stuff like that. Now, if you have, and it's a little bit dark, sorry. Oh, I bet you I can make it brighter. Did that make it brighter for you? Didn't do anything. Okay. Oh, well. If I do 2/3 plus 1 and I push Enter, one of the frustrating things that students sometimes have on this calculator is it gives your answer as a fraction, and you want your answer as a decimal. Okay? So on this calculator, what is really cool is this button right here, the S to D. Changes it from standard to decimal to standard. So I have 5/3. If I push it once, it changes it to 1.6 with a bar over top. What does that mean? 1.6 repeating. If I hit it again, it actually changes it to how most calculators would answer it with 8 numbers, and it's rounded the last number to 7. If I hit it again, it changes it back to a fraction. So I can do all sorts of math, right? 9 plus 3, well, let's do divided by 7 minus bracket 5 plus 2/3. So if I do that all at once in my calculator and push equals, it gives me an answer as a fraction. I hit this button, S to D. It gives me as the repeated decimal. I hit it again, and it gives me as just a regular decimal, which is pretty cool. So that button, the S to D button, I would suggest you keep things on your math section so you can use the fractions and type things exactly as you see them, but then when you want your answer as a decimal, you can. So then number 1, and now, oh, it's still doing that. Okay, oh, here. Okay, I will figure out on yours. This one doesn't have that, no. I've got to figure, and I'll figure out yours. No. No, this one doesn't. Okay. question? Is yours doing the same thing? Oh, yours is doing, yeah. I've got to figure out your models because there's a mode set up on it, and I'll figure out how to get rid of it. Yours works? Okay. Yeah, so you have to go, because it's in green, you have to hit the green button. Okay, then you get your fraction. Okay, so, and we're going to use fractions in the tangent ratio because a tangent ratio is always the opposite side over the adjacent side. This is a definition. You have to have this memorized. Is it on your formula sheet? Oh, it is. I wish they took this one off. Because you know what? In fact, you're going to have this memorized so well that you won't need your formula sheet of this ever. But the tangent is the opposite side over the adjacent side. So what that means, this is very powerful, is no matter how big or how small you draw a triangle, the angle always stays the same. The ratio always stays the same. So for example, if I draw a triangle and let's say I make this side 1 and this side 2. We're going to be able to, in this class, figure out that the answer to what is this angle is 26.565 degrees. This angle, I'm not telling you yet, but eventually we're going to be able to figure out that that angle is 26.56 degrees. If I take this triangle and make it bigger, I double this side and make it 4. I double this side and make it 2. Does it make sense that the angle doesn't change? If I drag it right on top, look at, wow, that's not what was supposed to happen. Basically, I mean, I drew it. There's going to be mistakes in drawing. But mathematically, this is also going to be 25.565. No matter how big or how small I have it. So what your calculators have in there, your calculator has memorized that if the opposite side is 1 and the adjacent side is 1/2, or the ratio, notice if I take the opposite over adjacent, I get 1/2. Over here, if I take the opposite over adjacent, I get 2/4, which is a fraction you could reduce to 1/2. And if any triangle ever reduces to 1/2 with the opposite over adjacent, the angle will always be 26.565 degrees. But we don't know how to figure that out yet. That's our goal in this unit. Our goal is, in this unit, how to be able to figure out the angles if we know the ratio, or the sides if we know the angle. Okay? So I could get you to actually solve this question right now. Problem-solving question. I'm going to draw a triangle. I'm going to tell you that this angle is 25.56, that's ugly 5, I'm going to tell you that this side is 7. How long is that side? Is it? No. Close. 14. This is going to equal 14 because you know how the tangent ratio works. The tangent ratio says no matter how big or how small a triangle is, if the angle stays the same, the ratio of the opposite side over the hypotenuse will always stay the same. Question? It's 26. I screwed up, right? Yeah. And that's, yeah, I'm sorry. Thank you. I figured it out with my calculator, what it was supposed to be, and we're going to, in this unit, learn how to do that. So, at this point, all you need to know, is the tangent ratio for the same angle stays the same no matter how big or small the triangle is. So the tangent ratio for 26.565 happens to be perfectly 1 over 2. In fact, if you go to your calculator, and I rounded it, so it's going to come out close to this. Wow. My calculator is being slow right now. So I'm just getting things cleared out here and ready. If you push the tan button, which is on your calculator, find it somewhere, and we type in 25.565 and enter, we get 0.47. Rounded to one decimal place, can you see that that's 0.5? Oh, and that's what I did. Thank you. Okay, tan. I did it again, 26.565. See if this is even closer to 0.5. Wow! What the tan button on your calculator gives you is the decimal of the fraction. Can you see that the decimal that I got is really close to 0.5? And so that means that the opposite side divided by the adjacent side has to equal 0.5. What's 1 divided by 2? 0.5. What's 2 divided by 4? 0.5. What is 7 divided by 14? 0.5. So let's see if you understand this. I want you, I'm going to give you a number here. 30, what number do you want? 30 what? 37. Oh, I like 37. 37 degrees. I need you to write a number in here and a number in here, and I will check them once you have those numbers to see if you're right or wrong. There's a million right answers. Well, there's an infinite amount of right answers for this. There's also an infinite amount of wrong answers. So you have to tell me a number to put in here and a number to put in here. You're going to need your tan button on your calculator, and you're going to need to type in tan of 37. And you have to put numbers in there that make this work. Yeah. And you have to hit mode and be in degrees. Now you get the same. If you're not getting 0. Yep.
Are you doing category weighting again?
No, I'm still going. I'll make sure you do that at home. So the next question we're going to look at is it says, determine tan of D. Now, tangent is always the opposite side divided by the adjacent side. So if I want to figure out what tan of D is, I'm looking at this angle right here. Which side is opposite of D? The 3 or the 4? The 3. Which side is adjacent? The 4. And this is all we have to do. If it says find tan of D, you just write it's 3 over 4. Can you see that that would be different than finding tan of F? And I'll do that in green. Because now what's my opposite side? The 4. And my adjacent side? The 3. So we have to memorize that tangent is the opposite over adjacent. And if I'm looking at F, then my opposite side straight across would be the 4. My adjacent side right beside would be 3. You know what's the most common way that people remember that tan is the opposite over adjacent? They learn the word TOA. How does the word TOA help you remember that tangent is the opposite over the adjacent? So, tangent opposite over adjacent, you remember TOA. Okay? TOA. TOA, TOA, TOA. Next question. We are going to learn a new button. On your calculator, there is an inverse tangent button, which is usually located right above the tangent button. How does this work? Well, first, it says if I want to find angle K, and I'm going to do this in green, can you see, because of TOA, that tan of angle K is equal to, what's the opposite side? 9, and the adjacent side? 13. And if I do, on my calculator, 9 divided by 13, I can get a decimal. It's 0.692. You could use your tan button to guess. Guess an angle. Yeah, Aiden, just any angle. See how close you get. 3. Tan of 3 is 0.05. Okay? Gage, guess another angle. 5. Tan of 5. Is he closer? A little bit. Riel. 20. Tan of 20. 0.36. What do we need? We need to get to 0.6923. 38. Ooh. Do you see that he went too high? So we're going to 36. 34. Oh, we're getting closer.
32.
Oh, 34 is too low. 35. 34.5. Okay. 34.6. Oh, I forgot the tan. 10. 34.6. Ooh. Okay, so we could keep going until we get closer and closer and closer. But what we're doing right now is we're guessing and checking. What your calculator says, if it has it memorized, shouldn't it have it memorized to go backwards? Just like your calculator has it memorized that 31 squared is 961. But it also has memorized that 961 is 31 squared. How does it do it? How does your calculator tell you that 961 is 31 squared? What button do you have to push if you just knew 961? Square root, right? Because the opposite of squaring is square rooting. The opposite of tanning is tan inversing, or tan minus 1ing. So what we do on our calculator is we can say angle K is going to equal the opposite of tanning is tan inversing. The opposite of tanning is actually spending winters in Winnipeg. Tan inverse of 9 over 3. So what we do on our calculator is often the tan button is above, tan inverse button is above tan. You have to push second or shift or something on your calculator to do tan inverse. Then I can go 9 divided by 13. And how close were we at 34.6? The actual answer is 34.6951553. That's the angle. So K, and it says to the nearest tenth, so if I round to 1 decimal, it would be 34.7 degrees. Pretty cool that your calculator has that built in. That's way better than guessing and checking. But the guessing, you guys got there fairly quick, didn't you? Yeah, it wasn't too bad. You noticed when it was going up and when it was going down. So if I want to now find angle N, I figured out that angle K was 34.7 degrees. And I want to find angle N. I could use the tan ratio again, or yes, they're going to add up to 180. So we could just add it up. So what is 90 minus 34.7? It's going to be 55.3 degrees. Just remind ourselves, I took 90 degrees, because these two would have to add up to 90 degrees. I subtracted 34.7 degrees. I got 55.3 degrees. Could you use tangent for angle N? If I switch to purple, I circle angle N. What is tan of angle N? It's 13 over 9. So I could go to my calculator and do tan inverse of 13 over 9. I should get 55.3. Let's check. Tan inverse 13 divided by 9, 55.30. Nice. So you could find angle N with your calculator, either using tangent or with our calculator using the fact that all three angles add up to 180. And you can actually use both of them to check each other, right? If you do one method, you could do the other one to check. Should be the same answer. Very cool. Okay. Clyde River on Baffin Island has a latitude of approximately 70 degrees. This is how they're designing their house with the roof. We found out earlier that if this angle of inclination is 70 degrees, then this is the best angle to get as much solar power as possible. So we have to decide, is this a good design or not? To do that, we need to find out this angle. Since the angle isn't labeled as anything, we use the Greek letter. The Greek letter. Do you remember what it's called? No, theta. So it doesn't rhyme with feta cheese. Not to be confused. You don't put Greek letters on your Greek salad. Okay? Theta. So then what we would do is we could say, well, I know that tan of theta, TOA, opposite of theta is 208. Adjacent would be 70. How would I use my calculator to find the angle? Opposite of tanning is tan inversing. $208 divided by 70, so I go to my calculator. $71.4 degrees. What do you think? Good design? Bad design? Would you say 71.4 is close to 70? Yeah. I'd say good design, since 71.4 degrees is close to 70 degrees. We have one more example. We've got a telephone pole and a support cable attached to the ground 5 meters from the base. So, can you draw a diagram involving a triangle that shows this? The cable is 19 meters long. So draw a diagram and label the sides. And your diagram should have a right angle triangle, so you have to decide where that right angle would be. And this is sometimes hard when you're first doing it. How to take, like, maybe you can imagine a telephone pole in real life, but how do you draw that on a piece of paper? What perspective do you have? Where would you draw your 90 degrees? Okay? So, can you see that if you would not draw this as if you were looking down from a helicopter? That would be a bad perspective to draw this from. You kind of want to draw it from a perspective where you have your ground and you have your telephone pole. Can you see that your telephone pole is where the 90 degrees would be? Okay? Now, depending on which way you saw it, some people draw the support cable this way, some this way. Does that make a difference? No. So whichever way you draw it, this distance here is 5 meters. And then the length of the cable, that's your 19. You don't label the 19 because they didn't tell you how tall the pole was. Could you figure out how tall the pole was? This is 90 degrees on this side. Well, how? A squared plus B squared equals C squared. Okay? What do we want? We want to what angle to the nearest degree does the cable make with the ground? So when we're asking for an angle, we're either, well, this 90 is the angle between the telephone pole and the ground. This angle would be the angle between the telephone pole and the wire. This angle is the angle between the wire and the ground. Why can't we use tan yet? We don't have the opposite side, but someone already said we could find it. We can find this side. Are you okay if I put a letter x here? And are you okay if we write that x squared plus 5 squared? How did I know the 19 had to go on the other side? Because it's the hypotenuse. Anybody know what 19 squared is? Yes, 361. Then we'd move the 25 over. So we get x squared equals 336. We go to, I would leave it as a square root of 336, but we could go to our calculator and have a decimal. Why is leaving it as a square root of 336 nice? Because it is exact. 18.33. If you used 18.33, it would be pretty accurate. But now I can use tangent. Okay? Tangent of theta. What number am I going to put on the top? What number am I going to put on the bottom? $19 or 5? 5. Because of TOA. Tan is the opposite over the adjacent. So we go to our calculator. Okay? I go to my calculator. I'm going to write it down first. Because opposite of tanning? Tan inversing. So if I tan inverse it, go to my calculator. I go tan inverse of the square root of 336 divided by 5. 74.74. Does it say to round this? Nearest degree? $75 degrees. Okay, this is where we're going to stop today, but first I want to just blow your mind a little bit. Okay? Beside tan, I've got cos and I've got sine. Check this out. Second, cos inverse. What? 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 How come that worked out to the same answer? Math. What do we learn tomorrow? Using tangents to calculate lengths.